So in the latest instalment in this occasional series on computer programming fundamentals, we're going to look at error trapping in your computer programs. Now, error trapping is quite important because if you don't do it and the user enters invalid data into the program will crash. And it will crash and it will go awfully wrong. And we don't want that to happen. Your aim is to always write programs that can't be crashed by what the user does to the program. So we're going to do this using a variety of techniques, and we have a number of functions we can call upon to help us do this. Now, in Visual, all the functions we're going to talk about, they're available in all the Visual Studio languages, so you can use them in Visual Basic, C#, C++, Java, and all the other fun languages we have in Visual Studio. We have this function, wonderful function called isNumeric. It's a Boolean function, so it returns a true or a false. We pass it a piece of data, and as it says here, because it's a function, we need to put it inside an if statement, or we need to use it in an assignment. What will happen is if data to check is numeric, the function will return the value true, or otherwise it will return the value false, and we use it like this. So we pass it a piece of data to check, which in this case is the text property of this text box. So in other words, the contents of the text box. And if that is a number, we can safely assign the contents of the text box to the number variable. If it wasn't a number, we could not safely make this assignment. So we would need to, in which case we would need to kick out this error message here saying we need a number, please. Now the important thing to understand is if we didn't code this error trap in and the user didn't type a number in, or they entered nothing into that field, that would cause the program to crash. So this little few lines of code here can stop your program crashing. Now once we've got verified that we've got a number, we might want to verify that it's in a certain range. So in this case, we're going to look at this is a range check. So a range check is defined as checking that a piece of data falls within a certain range between a lower bound and an upper bound. So we have a minimum and a maximum value. And we're going to check if we've got a number between 0 and 100, like a test result, a percentage test result. So in this case, we write if number is greater than or equal to 0 and number is less than or equal to 0, then we've got a number in the right range. Alternately, we could code it this way: if number is less than 0 or it's greater than 100, then it's invalid. Now we would do code these kind of tests inside a test, having checked that the number is already, we do have a number, we've verified that. But just notice for a moment, please, that you've got in the top statement, we've got an AND statement and the arrows are pointing towards the word and, the logical operator. In the bottom statement, you've got these comparison operators, the less than sign, the greater than sign, they're pointing away from the OR statement. So this is checking that the number is within this range, and this bottom one is checking the number is outside of the range from 0 to 100. It's important you code those the right way around, because logically these are opposites. Right, now we can also do range checks on letters. As it says down here, when we're range checking on letters, what the computer is going to do is it's going to use the ASCII codes in the ASCII table. So if you're not sure about that, go and look up the ASCII table, go and get an ASCII table out and check where the letters come into it. This is simply saying, does the letter come after the letter A in the ASCII table and less before Z, or before and including Z. And if that's true, we've got an uppercase letter. This one at the bottom is checking that we haven't got a lowercase letter. So notice we're checking it's outside of this range. So we're saying it comes before lowercase a or after lowercase z. Now, a little word of warning here. In the ASCII table, the letters A to Z and the uppercase and letters A to Z lowercase are not contiguous. In other words, they don't come one after another. So if you want to check that you have a letter as in uppercase or lowercase, you would need to actually code two range checks. One to check that letter was after capital A and before lowercase z, or letter was after lowercase a and before lowercase z. But I'm sure you can work out how to do that, and if not, please ask. Now here we're looking at numbers again, and in this case we want to verify that we've got an integer. So if you've asked the user to enter an integer, the way that we do that is using this function you can see over here called int. When you pass a number to the int function, the computer will convert it into its integer format. And just a word here is that if you pass it a decimal fraction, it will truncate that number at the decimal point. In other words, it will take 5.7 and turn it into a 5. It simply ignores the part of the number after the decimal, and it won't round it up. So what we do is we convert the number into its integer format, and if that is identical to the number itself, then we have an integer, otherwise we don't. Now, occasionally we have to work with dates. We want to check that the user's entered a valid date. We've got a function that will do that as well. Is date. Give it a date and it will say true or false. Yes, that's valid date. No, it isn't. So if you give it the 29th of February, for example, it will say true if it's a leap year and false in other years. If you give it the 34th of day of the 17th month, it will kick it out, and so on. If you're working with strings, something we often want to do is check the length of the string, and you will need to do this quite a bit. So we have a function called len, which can be used to check the length of the string. There is another way of coding this, which we'll cover when we talk about string handling, but we've got a C example at the bottom here. So what we've done is we've said we've passed password to the len function that comes out with the length, and if that number is less than 8, then it's too short, so we reject it. So this is the this is actually C as opposed to C sharp or C++, and this is the format to write this phrase here to the screen with a character return on the end of it. If we want to make sure the user has entered data, because if they don't, it will often cause our programs to crash, we can do it in one of two ways, which is we can use we can compare the contents of the text box to this value empty, which is just a bit a Visual Studio built-in. That means no data was entered. It's actually the ASCII character null. Or we can compare the contents of the text box to quote quote without no space between the quotation marks. Now, something else we might want to do is actually prevent the user just from typing in bad stuff in the first place. So we can do this using a key press event. Now, you'll notice we have this is just a code snippet. So if you look in the Visual Basic program, it will say private sub, and then we have the name of the subroutine. It will end key press, and if you follow it along to the end line, it will say then handles text box for .key press. In C, you would have a function. When you double click on the text box, it'll add the function. You'll get a piece of code that will look a bit like this. And what we add is we add this if statement here. So e.keychar is the character that the user typed into the text box. So what we're saying is if that comes before lowercase z or it comes after uppercase z, then we replace it with a nothing. In other words, we ignore it. So this will disregard anything other than lowercase letters being typed into this text box. Now, to use these events, what you have to do is, first of all, you add your little code snippet like this. And then once you've done that, you need to go to the text box in the properties, so that you would click on go into your form designer, click on the text box once, head down to the bottom right-hand corner of the screen, which is where you've got your properties. We click on the lightning bolt, this thing here. And then once we've done that, we then go into this field here and we type in the, we add the name of the text box, which in this case is text box 1 key press. Normally that would be txt username, for example. Now, we can also, sometimes though, if you say disregard any characters other than letters, one thing your user is going to have to be a very good typist, because if they make an error, they will not be able to press the backspace key, because when you press backspace, it generates an ASCII code. So what we need to do in that case is actually code it something like this and say, if we get a if we get a numeric key back and it is not equal to control-charge.back, in other words, the backspace key, then we replace it with nothing. And this will stop them pressing any button other than the backspace button. Now, if you like, the more advanced way of catching errors, so those are simple error traps, and those are the kind of things you should start to do in your programs automatically. So you should be checking that the user's entered values into text boxes. You should be checking that when they enter a number, it is numeric and it's the right kind of number and it's in the right kind of range. But when you're coding other things, like for example reading and writing files, or if you're doing advanced coding and talking to databases and the like, you'll need to write exception handlers. Now, an exception is simply an event that happens when something goes wrong. So if you, for example, try to convert a piece of text into a number, that will raise a typecast exception. In other words, it's saying the data is of the wrong type. If you try and read a file and you get a fault on the hard disk unit, it will generate a file IO error, these kind of things. So these are the kind of things that can be created. So an exception is an event that can either be happen because of something you've done in your code, like for example divide by zero, or it could be an event that's happened because of an external act on the computer, like you're trying to talk to a database that isn't currently started, you're trying to open a non-existent file and the like. Now, exception handlers are pieces of code that handle these named errors, these exceptions, and they're normally in Visual Studio they're coded as catch and try events. So again, this is Visual Basic syntax, which is virtually identical to C# syntax. So the format of the statement, this is actually straight out of the Visual Basic guide, is that we have a try statement up here. We have the try keyword, and then we follow that by a bunch of code statements, which are the ones that we want to carry out. Now, you can exit this try statement in certain situations, like if you've just verified everything's correct, you would exit. You could say exit, and it will just jump ahead and carry on with the next piece of code. After the try statement, now we've got the catch here, and the catch is so we're going to carry out all these statements here, and if any of them generate an error, we are going to run the catch statements, which are right here. And as you can see, this will intercept an exception, which is a named error, and then it will run the catch statements. And the code will only run if that error occurs. So let's say, for example, we try to divide one number by another and we get a divide by zero. What we could do is in the try statement, we would do the division, and in the catch statement, we would write the code that we want to run if we do get a divide by zero. And then we have a finally statement down the bottom here, and this is a piece of code that's going to run regardless of whether we get the exception raised or not. So regardless of what's going on, run this. Note as well that the program will just continue to execute down. So any code after the exception handler, it would run in either case. So one way we can use these statements is we can actually write your own exceptions. So you can create an exception, for example, called user has typed in a number that's too big. And then you could simply say throw user has typed in a number that's too big. In this case, we're going to throw the file not found. So what file not found? So this would cause the exception handler for file not found to run. Here's an example. So what we're going to do is we're going to try and take the contents of the text box, and we're going to try and put that into number one. Now, if this text box does not contain a valid number, that will raise an exception. So in this case, we catch EX, which is the exception, and we simply show the error message for that. Now, the alternative to these lines of code here would simply be to code in your program number1 equals txt number1.text, so this line on its own. Now, if you had that line on its own and you had and the user didn't type in a number in the text box, your program would just crash it, keel over, and that'd be the end of it. However, with this piece of code here, what's going to happen is if the user enters a non-numeric value in the text box, you'll simply get an error message on the screen. And of course, what you can then do is in the exception, you can then tell them to re-enter the code, and then you can go back to the start and do things like this. So this allows you to basically write incredibly flexible programs that won't crash. Now, here we've got an example of how to catch division by zero. So what we're going to do is we're simply going to try and do our division. If you remember, this symbol here means integer division. So again, we catch the exception, and then we simply show it to the user. And with these with catch and try, you can write incredibly flexible exception handlers, and I would encourage you to try them out and have lots of fun with them. And that is all I have to say on the matter. Goodbye.